What's going on, guys? Welcome back. Today we're going to be looking at linked list implementation. So with the node in hand, we can start building the actual linked list. Depending on the end use of our linked list, a variety of methods can be defined. For our use, we're just going to focus on getting the head node of the list, adding a new node to the beginning of the list, printing out the list values in order, and then removing a list that has a particular value. So let's get started. So within script.pane, define an initial method for linked list. We want to be able to instantiate a linked list with a head node. So let's see, so this is the class. Let me reset it. Okay. So we'll do class linked list. And then we have to, of course, for every class, we have this. And then the method for linked list, okay, we want to be able to instantiate a linked list with a head node. So in it should take a value as an argument. Okay, let's take value. Self as well. Okay, and then inside of it, set it. Oh, and then we also need a head node. So that would be self dot value equals value self dot head node is equal to a new node with value. Okay, so node and value. Nope. Okay, did you give? Yep, with self and no. Okay, so this one get rid of. Did you give value a default of none? Good question. Now we got it. So yeah, there you go. So we defined a initialization method with self and value, and then we defined or we set self.value equals the value, and then the head node is equal to the node with the value, which is equal to, of course, none as the first one. Define a get head node method that helps us pick up the first node in the list. Inside the method, return the head node of the list. Return self dot head node. There you go. So we're defining get head node. We set self in there, and then we return self.head node. Fantastic. And then let's go ahead and take a look at the second implementation of it real quick. So far we can create a new linked list using the initialization function, and then get the head node using the get head node. Next, we'll define methods for our linked list class to allow us to insert a new method, a new head node, and return all nodes in the list as a string so we can print them out. So let's see, okay, define a dot insert beginning method. So this was already built. Let's see, okay, so this we're just going to reset it. Okay, right here. So define what is it called? Insert beginning method that takes a new value as an argument. So we'll give it self and then new value as well. Okay. And inside the method, instantiate a node with new value. So name this new node. New node equals node with new value. Okay. Now link the new node to the existing head node. So head node equals head node equals new node dot get value, I think. And finally, replace the current head node with the new node. Yeah, can I get some guidance here? So self, yeah, new node, okay, we got this part, and then new node dot set next node dot set okay, and then you do self dot head node, and then of course you self dot head node is equal to new node. Okay. Did you define called insert beginning? I think I spelled it wrong. Yeah, that is. That's what we have. Let me see what's going on. Define insert beginning. New node equals node new value. New node dot set next node. Remember we defined that. We defined it here. Okay, and then there's our issue. There we go. Okay, and then define a stringify list. So the def stringify list. So we can print out a string representation of the list node's values. The method should traverse a list beginning at the head node and collect each node's value in a string. Once at the end of the list has been reached, the method should return the string. You can use string to convert integers to strings. Okay, so we'll do let's see, okay, it should traverse a list, right? So for let's see, let's get some guidance on here, right? Okay, inside your string list body, start with a variable to set a empty string to collect all the nodes. Okay, so let's start off with that. So we'll do string list of that, right? And then you can use a while loop and the nodes dot next node method to traverse the list. So counter equals 0. If If you accidentally get stuck, just use your browser to reload the page before editing your code. Don't worry, we've all been there. Okay. So let me see. Support. Okay. Let's get some help with this. Can you help with this? Okay, so start with an empty string. Okay, we do. Use a variable to keep track of the current node, starting with the head node. Use a while loop to traverse the list until the current node is none. Wow, got it, okay. And then inside the loop, append the current node's value to the string, move to the next node. Okay. So of course we have self in here. Okay, current node, right? Current node is equal to self dot head node. Okay, so we're just gonna copy this and then let's figure out where we got stuck. So let me go ahead and see where we got stuck exactly. So define stringify list, string list, current node equals self.headNode, while current node is not none. String list plus string value equals this. So current node dot get value. So we're just adding all of the nodes onto it, basically. All right, and then test your code by uncommenting the print statement at the bottom. So let's go ahead and do that. Did you uncomment the print? Okay. So we get 97, 5,675, 70, and 5. Because we get that because again this is inserting it all the way to the beginning and then we're stringifying it and we print it out one by one because this is adding it to the beginning. But that is linked list implementations, and then the last one here we'll do really quickly here is now that we have a bunch of helpful linked list methods under our belt, the final use case we mentioned was the ability to remove any arbitrary node with a particular value. This is slightly more complex since a couple of special cases need to be handled. Consider the following list. So we have A to B to C. If node B is removed from the list, the new list should be A to C. We need to update the link within A node to match with that B was pointing to prior to removing it. Lucky for us in Python, nodes are not referenced, which are not referenced will be removed for us automatically. If we take care of references, B will be removed for us in a process called garbage collection. For the purpose of this lesson, we'll create a function that removes the first node that contains a particular value. However, you could also build this function to remove any nodes by index or remove all nodes that contain a particular value. So at the bottom of script.py, add a dot remove node. Okay. itself in it. Okay, we should take a value to remove as a parameter. Value to remove. Okay, set a variable current node. Set a new variable current node equal to the head node of the list. Okay, current node equals head node. And then we'll use current node to keep track of the node we are currently looking at as we traverse through the list. Head node is not defined. Let's get some guidance here. So you can retrieve the head node by using the get head node. Okay. Get head node. Get head node is not defined, right? Self.current node is equal to that. Current node is not defined. The current node is not defined. Let's see. Oh, it's self.getNode. Oh, okay, self.getNode. So current node is equal to self. Okay, so you can do that. That'll fix it. Okay. Now, still inside the method body, use an if statement to check whether the list's head node has a value that is the same as the value to remove. Okay, if head node dot get value equals value to remove. If it does, we found the node we're looking for, and we need to adjust the list pointer to head node. Inside the if clause, set the self.head node equal to the second node in the linked list. So self.head node is equal to self equal to current node dot get next node. Head node is not defined. Head node is not defined. Let me see. Are we supposed to define a head node? No, we don't. Let's see. If current node is equal to dot get value, yeah, I have that. Oh, if current node. Okay, if current node, right? Not head node, sorry. Okay, there we go. And then add an else condition. Within the else clause, traverse the list until current.head node is the else. Not equal this. Just like the stringify method, you can traverse the list using a while loop that checks whether the current node exists. When the value to remove is found, adjust the link so that the current node is linked to the next node dot get next node. This one we might need some help for that. Yeah. So we're gonna take a look here. So if head node equals, okay, if head node equals, so we're good up until here, and then when we get here, while current node says next node equals current node, else this. Okay, let's take a look. So that's basically how it works. So basically, we remove node self and value to remove. If we set the current node equal to the head node, and then if the current node is equal to the same value as we want to remove, then we simply just make the head node equal to the next node, basically, because we already removed the current node. And then else, while we have the current node, the next node is equal to the current. The next node is equal to the next node, and then if next node's value is equal to what we want to remove, then we, of course, we remove it, and then we set it to the next node, and we set current to none. And then else current node equals next node. So we just keep going until that happens. And then a little linked list review here. Congratulations, you've implemented a linked list in Python. We did this by defining a node class to hold the values and then implementing a linked list class to external operations on the list, adding and removing nodes. Feel free to play around a bit with your code. Here are some ideas. So create a few nodes, adding them to a new linked list. Print your linked lists by using your stringify list method. Remove linked lists, the head node, print your list again. And yeah, so that's basically a linked list in a nutshell here. Did that. In the next video, we'll be taking the quiz for the linked list, so stay tuned for that, and I'll see you in the next one. If you're looking for jobs and internships, check out the top link in the description down below, or if you're a computer science student, check that out. If you enjoyed this, consider subbing, and have a fantastic day.